In this first concept check question, you're asked to draw the products of the reaction shown. Let's start by identifying the nucleophile, electrophile, and leaving group. And then let's determine if this is an SN1 or an SN2 reaction. The nucleophile is the CH3CO2 anion. This is an acetate anion. The electrophile is the carbon of the alkyl chloride, and the chlorine is the leaving group. This is a secondary alkyl halide, so it could go through either an SN1 or an SN2 pathway. And we'll need to look at the other reaction features in order to figure that out. The nucleophile is a weak nucleophile. It's the conjugate base of a good acid, and the reaction is run in a protic solvent. Also, even though the alkyl chloride is a secondary halide, it's benzylic, so a carbocation will be more stabilized in this position. So here the reaction will favor an SN1 pathway through a carbocation intermediate. Remember, that means that the product will form as a racemic mixture. In the second concept check question, you're asked to draw the products of the reaction shown. Let's start by identifying the nucleophile, electrophile, and leaving group. Then we'll determine if it's an SN1 or an SN2 reaction. The alkyl halide is a primary alkyl halide, so this reaction will almost certainly go through an SN2 pathway. The nucleophile is also a strong nucleophile, methoxide, and the reaction is run in a polar aprotic solvent. All of these reaction features favor the SN2 pathway. Remember that there are no intermediates in an SN2 reaction. Instead, it proceeds through a concerted pathway in which the carbon leaving group bond breaks and the carbon nucleophile bond forms in the same step, or the same transition state. The product that we get from this reaction is the methyl ether. In this last concept check question, you're asked to draw the products of the reaction shown. Again, we'll start by identifying the nucleophile, electrophile, and leaving group, and then determining if this is an SN1 or SN2 reaction. This is a secondary electrophile, so the reaction could go through an SN1 or SN2 pathway. So here again, we'll need to look at the other reaction features to help determine the pathway. The nucleophile is a good nucleophile, and the reaction is run in a polar aprotic solvent, acetonitrile, and both of these conditions favor an SN2 pathway. Again, the SN2 pathway has no intermediates. The nucleophile directly attacks the electrophile, but remember that this attack occurs via backside attack and with inversion of the stereochemistry. So while the leaving group was pointing back away from us, the bromine, the nucleophile, will be pointing toward us in the product.